besides traveling by car or, driving, you have many different islands, which is like the ferries, or the boats. So maybe in terms of culture-wise, maybe you wouldn't talk about a short drive. Maybe you talk about a short trip by ferry or something to travel. Yep. Okay, I can see people trying to give some sort of ratio. That's quite interesting. Yep. Yeah, cool. Keep sharing. Thanks. So, so this is an example of numeracy as well. When we talk about the sense of scale, we talk about, linking it to the lives and the daily lives of the things that, the things that we experience. Yeah. Okay, let's go on to the next. Yeah. Okay, cool. Keep your comments coming. Yep. Let's go on to the next slide, unless there's anything you want to add. Okay, so now, yeah, we want to hear a bit from you because, we know that you are teachers. So what do you teach? Can you share, like, what subject and what grade do you teach? So, yep, biology, mathematics, okay. Yep, some secondary, some sixth grade, okay. Yep. Oh, okay, I see. Yep. So we have a lot of, we have some elementary, okay, also a number of mathematics, ICT, okay, can see that. English, cool. Yep. Science, English, science, okay. Yep. Mathematics. Yep. Wow. Okay. So technology, okay. Yep. English, souls, oh, okay. Yep. Oh, that's nice. Okay. So there's a range of people at a glance, yep. From elementary to secondary. Yeah. Cool. Thanks. Okay. Keep going if you haven't. So maybe we can ask the next question, perhaps. So, okay. So, yeah. So keep going. The next question to ask you is, when do you use... Oh, what was the arrow? Yep. When do you use mathematics in your everyday life? Yeah, when? So how can you give an example of when? Okay, so somebody said shopping. Okay, yeah. Shopping. So besides shopping, when cooking, yeah, okay, cooking, buying things, yeah, playing games, yeah, driving, okay, counting, scores, yeah, sports, yeah, building, okay, swimming, okay, running, yeah, running, okay, looking at the trees, traffic lights, okay, playing games, scoring, eating, yep, okay, everyday activity, yeah, traveling, yeah, traveling, walking, yeah, even the time, like this talk, right? When I look at the time, because it's 9:30 or 9:30 WIB. So when I went to check the time difference, I realized that there are 3 official time zones that Indonesia has. So I thought that was very interesting because when you want to meet your friend or have some sort of online session or organize some events, you have to be really aware about the time zones and what time, yeah, the sessions are. Okay. Yep. Okay. Sports training and yep, cooking. Yep. Okay. So looks like, you've been using a lot of numeracy actually. So, yep, climbing. Okay. Praying. Yep. Shopping. Okay. Yeah, that's great. Okay. So maybe we can move on to the next slide. Okay, so I think there were some people who are trying to use the annotate function, right? Let me see if I can clear that annotation, if that's possible. Yep. Okay, so excuse me. So mathematics is used. What is numeracy? So actually numeracy is when you use mathematics in context, in a context. So, here you can see some pictures, and this is what you have mentioned here. So it will be, you use mathematics in cooking, so when you are making the kueh, you want to find out, okay, how many eggs should I use? Or, what is the measurement? How much milk maybe, or, sugar do I need to put in, or coconut cream? How many cans? If I want to make for how many people, you have to use a lot of numeracy to go and check with that. So, like when you go shopping, of course, you got to look at your budget. You got to look at how much it costs. Or, when you're playing sports, you decide to count the scores, maybe your games, like your sepak raga, maybe, or the dance. This one is from one of my, the Indonesian student was sharing an activity, a numeracy activity, which is to use the mathematics in context. So my student mentioned Tari Saman, which is the dance, right? So, when you raise your hands, you must check out the stage, how big is the stage, what is the angle that you should raise your hand so that it all looks symmetrical, look nice, and matches. So you can see from this image of the Tari Saman, the dance, you can see the numeracy and appreciate the beauty of that in there. And of course, in this time period, right, with the pandemic on, I'm sure we watch a lot of news and read a lot of information about the coronavirus. Or, you can see a lot of like the graphs of the dailies, information, and so on. So there's a lot of mathematics that you have to read, you have to understand, you have to interpret and make sense of what does it all means, to understand the information, to interpret the information, to decide whether, okay, is this correct or not? Is it critical? Who is the one who presented this? Is the presentation or representation appropriate or not appropriate? Is it meant to make you feel something, stressed, make you feel frightened because of the kind of presentation, the way that they present the graphs or the information? So we need a lot of mathematics and numeracy skills there. Okay, yep, and I can see more. What is PMRI? Okay, that's very interesting. Yep, daily use. Okay, so maybe you can explain a little bit more. Okay, so maybe some, we can have a chat later. So keep going with your comments. Yep. So to be numerate. So what is numeracy, right? So just now we mentioned about to be numerate is actually to use the mathematics effectively to meet the general demands of life at home or in paid work or for participation in the community and civic life. So this is a more formal sort of definition of numeracy. So the shorter definition just now we mentioned is to use mathematics in a context. So like in your daily life. So you've been doing a lot of numeracy. It's just that maybe you didn't use term numeracy. Okay, so let's go on to the next slide, please. Thanks. Yep. So what is the difference between numeracy and mathematics then? In case some of you might be thinking, oh, is maths the same, equals to numeracy? Is it the same thing? Or is there something else? So here, we just give you an example. So let's say mangoes cost 30,000 rupiah each. Okay. Of course, this is the price when you pay when you buy a mango in Australia. Okay. I know from inside sources. Didi, are you there? Inside sources. That it is only 10,000 rupiah per kilo, right? It's very cheap in Indonesia compared to Australia. Yeah. So in Australia, it costs about this kind of price, 30,000 rupiah. So you buy 4 mangoes, how much will they cost? So that's the numeracy question, because there is a context. You're buying mangoes, it's part of like shopping. You need to make use of it. Yeah, okay, I can see a lot of people telling me it's very expensive. Yes, yeah, the kind of living standards, or the amount of the cost of living is much higher in Australia, compared to Indonesia. So, all right, let's look at the difference. So, what about mathematics? So, next, click. Yep. So, in mathematics, when you talk about the mathematical skills or the content, right, it's actually just, what is 30,000 multiplied by 4? So that's the mathematics behind it. So you make use of the mathematics to solve the problem, or to, in the daily life, to buy the mangoes. So you need to apply the mathematics there. Yeah. Okay. So hopefully this gives you a very simple example about what is the difference between mathematics and numeracy. Okay. Yep. Thanks. I can see there are a lot of maths teachers there to do the calculation pretty quickly. Yep. Okay. So, as I said, this is the difference between mathematics and numeracy, so that hopefully you're not confused by the two. So, that's okay. All right. So we just go on. So sometimes numeracy is also called mathematical literacy, which is to use and apply mathematics in different contexts. So, for example, when we compare the area of the different countries, just now, the land area of the different countries, we are using quantitative literacy and spatial literacy, because you try and look at the space, right? The visual you make use of your visual spatial kind of skills, and you try and do some sort of estimation. So you make use of that. And of course, when we look at the statistical information, of COVID or population statistics or students' results, we are actually using statistical literacy. Okay, so teachers actually all teachers should have some statistical literacy as well. And of course, your mathematical literacy, quantitative literacy, spatial literacy. And mathematical literacy, yes. So just now I mentioned, numeracy is the same as mathematical literacy. So it includes all the other types of literacy, such as quantitative literacy, spatial literacy, statistical literacy, financial literacy. Financial literacy, I don't have to say too much, because about, how to budget, how to save money, travel to Australia or Indonesia. We have to save money to travel. So we all need some financial literacy. And all this is part of numeracy. So that's, so this Venn diagram at the bottom represents it. So you can see they're all overlapping circles, because, you need some of these and they overlap, those skills overlap actually. So, and they're all part of numeracy or mathematical literacy. Okay, yes. Yep. Okay, I can see people getting the idea about what is numeracy, a better idea about what is numeracy. Or what is spatial literacy? I think somebody asked. So, maybe some. So, spatial literacy is when you look at this visual part, you make use of your concept. So, like, for example, just now when I mentioned about the size of the different countries, when you do the comparison, you're actually looking at it. So there's a sense of the space. And when you do your dancing, also there's a sense of space. You need to make some estimate. So also when you are sewing or cooking or dancing or building, you need that spatial sense, So you need to be able to know, okay, how far is 1 kilometer? Um, yeah. And how far is it from one place to another place, that kind of thing. What is the size or shape of your room? So you need that sense of space. And of course, the mathematics associated with it. Yeah. Jennifer, do you want to add anything?
Yeah, so just to reflect what Hazel said, as well as some of the comments people have been saying. So just to be really clear, numeracy and mathematical literacy, those are synonyms. So if you hear those words, they mean the same thing. And certain countries use one term more than the others. So like in the US, they use mathematical literacy more, whereas in Australia, we say numeracy. And then like you'll see certain tests like the PISA test or the TIMSS test, those international tests might use different terms, but if it's either numeracy or mathematical literacy, those are the same. Whereas the 4 types that are shown in the smaller circles, those are like subsets or subtypes. So they're all types of numeracy, just with a different focus. So like Hazel was talking about, like with map reading or dancing or whatever, those are spatial things, right? Because it's about a sense of space. Whereas if you're looking at like using money and budgeting and making change and so on, that would be financial literacy, right? Maybe understanding coins and bills and, what they mean and how they relate to each other. Whereas the quantitative literacy is more kind of like the basics, right? So being able to add and subtract and read numbers and count and whatever, which is, you need to use those basic skills, in the different types of numeracies. And then the statistical literacy, again, anything involving data and statistics.
Yep. Thanks, Jen. So, yeah, I think there's still, it's okay to start thinking about it because, keep thinking, keep discussing, because we will, get back to it. We have already told you an example was that when we compare the area of the countries, that's an example of how you can make use of your spatial literacy to make an estimate. Yeah. So, okay, maybe we can go on to the next slide.
Okay, so now I'll go into a history of numeracy as a concept or as an idea. And a lot of people think like, oh, numeracy, this is this like newfangled thing, that it's only come out in the last 5 or 10 years. But in fact, numeracy is quite an old idea, way older than Hazel and I. So it actually came out in 2 big reports in the United Kingdom. And the first one was authored by a man named Crowther way back in 1959. And Crowther was really ahead of his time because the way he talked about numeracy is that it's a mirror image of literacy, or almost like a parallel to literacy. And this is actually a definition or a way of talking about numeracy that people still use today. So people will say like, okay, well, English is like math, that's the parallel. So then numeracy would be the parallel to literacy, right? So it's like applying English in a context or applying math in a context. So this is a really important idea that Crowther came up with, way back in the 50s. Then in 1982, another UK researcher and educator, Cockcroft, published a really influential report. And the point that he made that, again, still applies, 39 years later, is that numeracy is the responsibility of all teachers. Because people used to think like, oh no, just the math teachers, need to worry about mathematical content. But what Cockcroft was saying is that no, it doesn't matter if you're teaching phys ed or you're teaching dance or drama or geography or whatever. It doesn't matter what you're teaching and what grade level. Everybody should be numeracy, and everybody should be developing students' numeracy capabilities. So, if you're the gym teacher and you're out doing track and field, and, the students are doing the long jump, where you just stand and you jump, and then they're measuring, well, how far did you jump versus how far did I jump? Well, you as a teacher, even though you're not the math teacher, you're the gym teacher, you still have to make sure that the students are using the measuring tape properly, or the trundle wheel, or whatever tool they're using, right? And that they're applying their mathematical skills appropriately, in the context of a gym class, or, maybe you're an art teacher and you're teaching students about how to do perspective drawings where it looks like you're looking down, a roadway or a laneway. Well, how do you draw the lines? What's the angle that you draw them at so that it does look, just like it would look with your own eyes, but in your drawing on the paper? How would you draw those angles? And again, of course, you would need to use rulers and other mathematical tools. So this is what Cockcroft was saying, almost 40 years ago, that all teachers of all subjects, should be incorporating numeracy. So, you can see, right? Like, I'm sure a lot of you folks already are doing a lot of this, just like Hazel mentioned earlier when you said about your everyday life and your shopping and cooking and sports and so on. You're already doing numeracy in your everyday life, and you're probably already doing lots of numeracy when you teach these other subjects, but maybe you just, weren't aware, or maybe you just didn't know the term. But now you can be like, oh, wait a sec, that project I did the other week in geography class, oh yeah, there was some spatial sense in there, there was some measurement in there. So that would be an example of numeracy. Which is great. And that's the thing, right? Sometimes it's like you've been doing something all along, but maybe you just didn't know the word for it, right? You didn't realize that there was this concept or this term. But like I said, these actually are terms that have been around for a really long time, but, just maybe not as publicized, or, maybe not in some countries as much as other countries. Like, for instance, for me, coming here in 2015 from Canada, like, we don't really say numeracy in Canada. We say mathematical literacy. So I was like, oh, what's this numeracy thing? And then I realized, oh, it's just the same. It's a synonym, right? But in Canada, because, we're beside the US, we tend to use the same words that they do, whereas in Australia, and the UK tend to use more similar terms. So it's just something really important to keep in mind. Okay, so now we're going to get into this 21st century numeracy model. And this is a model that's used a lot, not only in academic publications like journal articles and so on, but also in a lot of curriculum documents in lots of different countries. So this looks very busy and there's lots going on. So I'll unpack it for you slowly, just to make sure that you understand all the little pieces. And as I always say to my students, I don't think the graphic design is the prettiest, but the content is good. So any of you folks that are artists or graphic designers, you might be like, could have made this prettier, but the content's really good. So we're going to start with the small triangle in the middle here. Okay, so you'll notice this triangle here says context. And on each vertex of the triangle, there's a different term. So we've got citizenship on the top vertex, personal and social on the bottom left, and work on the bottom right. So what this is saying, and why this is in the middle of this image, is like what we talked about and Hazel mentioned earlier, right? For something to be numeracy, not math, you need to have a context, right? So if it's just what's 5 plus 7, that's just a math question, right? It's just numbers. It's not in a context. There's no situation. Whereas if there is some kind of a context, some kind of a real application, then it's numeracy. So for instance, you could think of examples, from your personal life or social interactions, like maybe you go out to dinner with friends and, you share a few dishes, and then the bill comes and you're like, oh, are we just going to divide it by 4? Is that fair? But you had a drink and I didn't have a drink, but you had the appetizer and I didn't. How are we going to divide this up, right? So that's just a simple example of where you might be using your numeracy skills just in your personal life. And then in a work context, there are different levels of numeracy depending on the job, but I mean, everybody gets a paycheck. Everybody needs to deal with that, no matter what your job is. But you can think of lots of, obviously, as a teacher, you use lots of numeracy like we've discussed. But I mean, if you're someone who works in a medical field, you do a lot with measurements, right? And looking at doses of medications, or if you're like reading an X-ray or an MRI, right? You have to look at different measurements. If there was like a growth or like the length of a bone, maybe as a baby's developing, right? So lots of different measurements you might do there. If you're someone who works in construction, lots and lots with angles, right? Lots of measurement there, right? How do you put, joints together of, pieces of wood? How do you decide how high the ceiling's going to be? Where are you going to put the framing for the house, right? There's lots and lots going on there. So just a couple of examples. And then in terms of citizenship, this is, how do you participate in your country or your state or your province as a citizen in terms of understanding like policies and bylaws, in terms of voting, right? And lots of countries have different systems, whether it's like first past the post, or is it proportional representation? Is it a rank ballot, right? And understanding all the mathematics involved there to do your role as a citizen. So that's the small triangle there in the middle. So again, why it's drawn that way is that it's at the heart, right? By definition, you have to have a context. If there's no context, then it's just math, right? If it's just 10 times 10, that's just math. But if it's like, I'm buying 10 t-shirts and each t-shirt costs $10, then that would be a numeracy example. Okay, so now we're going to move up to the big triangle. And again, you can see we've got different terms on the vertices. So if we start here at the top left, you can see a few different dispositions listed. So confidence, flexibility, initiative, and risk. So what Goose and colleagues who made this model, what they're saying is that like it's not good enough to just know the math, but that you're willing to actually do it, when you're in a situation. You're willing to figure out how you would double the recipe or half the recipe, or, figure out how much paint you would need to buy to paint your bedroom, that you'll take that risk. And also being flexible is really important, because a lot of the time, the way we do math, when we're in the quote unquote real world, is not what you do in math class, right? You don't use the algorithms and the long division and whatever. You'll often solve things flexibly and do things in different ways. That's the dispositional side. Then if we go to the top right-hand side here, you can see different tools. So again, to be numerate, you need to know how to use different tools. So the first type of tool is representational tool. So this is things like graphs, maps, diagrams, tables, right? So some kind of a 2D representation of data or some other kind of quantitative information. Then you also need to be able to use physical tools. So like knowing how to use a ruler, knowing how to use a protractor, that kind of thing. So something you would hold in your hand. And then also using digital tools. So like using software programs, like, maybe using a spreadsheet program like Excel, and understanding like, how would you write the formula if you wanted to take an average, of students' grades? What would you write at the bottom to figure out that average? Or what if the assignments had different weights? This was a 20% assignment, and this one's a 30%, and this is a 50%. Well, what formula could you write to figure out what the total grade was? So that kind of thing within like a computer program or a digital tool. Then the bottom aspect of the big triangle here is mathematical knowledge, which obviously, right, you have to have mathematical knowledge or you're not numerate, right? So understanding different concepts and having different skills. But the top 2 points that are listed here, problem solving and estimation, are really important because when you're doing math in the real world, in a context, right, you're often doing it because you need to solve a problem, right? You need to figure out how many, of whatever you need to buy for your party or to make the cake or whatever, you're solving some sort of a problem. And oftentimes, when we're doing math in the real world, when we're doing numeracy, it's totally fine to just estimate, right? Lots and lots of times we don't have to be precise. And I'll give you a really simple example from this morning. I was having cereal for breakfast and I just dump it in, right? I didn't get my measuring cups out and be like, okay, I'm going to have a cup of cereal. I just kind of dumped it and eyeballed and I was like, that was fine, right? It doesn't have to be precise. Is it enough? Am I full? Good, right? That's all that matters. Whereas, sometimes there are situations when you have to be really precise. And again, to use another example from this morning, I have to take medication in the mornings. And you definitely do not want to estimate when you're taking medication. When you're like, that's about 5 milliliters, looks good, right? You've got to be specific or, you can get really sick. Right. So that's an example where you have to be very precise and specific. But a lot of times in everyday real world math, it doesn't matter. You can just estimate and that's fine. Okay, so that's the dispositions, tools, and knowledge. And then last but not least is this cloud here that goes under the great big triangle and all the little triangles. And that's the critical orientation. And so the idea with the critical orientation is basically that you're like a critical thinker or you have a critical lens when when you're faced with mathematical information or statistics, or you get an answer to something you've worked out and you're like, does that make sense? Which is kind of like what we were talking about with the maths. Should it be about 100 times, about 10 times? Right. And I'm sure any of you folks who are math teachers, right, you have the students who are like, boop, 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 boop. They just type things in their calculator, they get an answer and they just write it down. And they don't even think, does it make sense? Right. So they might get an answer that's like 7.2, but the question was saying, how many people are in your family? Well, you can't have 0.2 of a person, right? So that kind of thing, you have to see, does it make sense in the context? And especially with when we were talking, Hazel was mentioning about the statistical literacy, right? So the COVID data or climate change or, anything like that you see in the media, how do you know that that's right? How do you know that you trust it, right? So having the skills to look at, who is the source? From whom did they collect the data? Was it a biased sample? Right? All of those types of things come into the critical orientation. Just check if we have any questions here.
Yep, I think there are lots of questions around, but maybe we can address. I think one question that a lot of people asked was whether can the slides be made available. Definitely, we can share the slides with the host, and then I'm not sure how it will be passed on to the teachers, but maybe Melly will be able to answer that. Yep, whether the slides will be shared with the teachers. Yep.
Yeah, but we're happy to share them. That's fine if you want to review. Yeah, but I think a lot of the questions that quite a few people have mentioned is, well, how do you make math interesting to students? And I think a lot of what we've mentioned is a good way, right? When it's just numbers that are by themselves and they don't mean anything to the students, students check out and they're like, oh, I hate math and I'm not a math person, right? You've probably heard that, right? And that's not what we want. We want people to understand math and appreciate math and feel that they are capable, that they can do it. right? So making these connections like we've talked about with the numeracy, that's how you can get kids engaged. And, Hazel and I have even seen this. I mean, we've both taught people that are training to be secondary teachers who were, from arts backgrounds. They were going to be dance teachers or art teachers or whatever. And often they would say to us, like, oh, we're not math people. We don't like math. We're not good at math, right? That kind of thing. But then interestingly, we did a week of this unit that Hazel and I teach in the Master of Teaching program. We did 1 week all about numeracy in the arts. And those people were so engaged and so involved. And you could see they felt so confident because they're like, oh, yeah, this is how it works in music. I'm a musician. Let me tell you about time signatures. And, that they really understood the concepts and they were really interested in them because it was an area, that was an interest and expertise to them. So that was a nice way to get them into the mathematics, by linking it to what they're personally interested in. And that's what you can do in your teaching, right? If your class is really into, a certain sport or a certain movie or a certain whatever, right? See if you can pull out those numeracy connections.
Yeah, maybe I can, because just now there were also people asking about the spatial literacy, like what is spatial literacy, and ask for an example. So I thought, okay, I can think of one example. You know how in the COVID days, we talk about social distancing? Social distancing, yeah. I think you have in Indonesia too. Yes. So how far should you be away from, what is the distance for social distancing? I think we use 1.5 meters. Yeah, 1.5 meters. I think maybe you're using the same social distance. So one of the first things I asked my student, when they came back from the lockdown is, okay, please find a partner and stand, 1.5 meters apart from each other. How far do you think is that safe distance, for the social distancing? So, how far is 1.5 meters? So they need to make use of their sense of the space. Because is it this far? Or, is it further or nearer? How far is 1.5 meters, So then after that, I gave them some tape measure and they actually measure, okay, is it further than they thought, or maybe they estimate this, how good was their estimate? Then they can adjust and have a better sense of that spatial distance so that they would know how far is actually 1.5 meters. Yeah. So this is just an example of the spatial literacy, and also very useful in these days with the COVID and social distancing.
Okay. Yeah. Okay, Dr. Hazel and Dr. Jennifer, actually we already have some questions that we have chosen. Can we display it in the screen?
Pardon?
I will share the screen for the question.
Oh, you want to share some questions on the screen?
Yeah.
Have we finished our presentation?
No, we're not quite done yet. We should have a couple more slides, sorry.
Whoops.
Oh, okay. You can continue your presentation if you want.
Yeah, we're almost done. Yeah, just another
Almost done. A couple more slides. But we thought it was a good time for question and answer because we were presenting the model. Yeah.
Okay.
Yeah. All right. So we'll just wrap up quickly here. So just to give you a quick idea of what numeracy is like in Australia. And so numeracy is a general capability in the Australian national curriculum that all the states and territories use. And so what that means, just like the reports out of the UK, way back, is that it's the responsibility of all teachers. So in every subject, in every grade level, you need to incorporate numeracy. Then, how do you get teachers that are ready to do this in their teaching? The government has introduced a test for pre-service teachers for literacy and numeracy. So they have to pass this test or else they don't get their degree. Okay, so you won't get your Bachelor of Education or Master of Teaching unless you pass this test. And what a pass is showing that you're the top 30% of the adult population in Australia with respect to literacy and numeracy. So the questions on the test are very much in those contexts like we talked about in the model. So in a teaching context, which would be a work context, and then like personal life type context, and then civic responsibility type context. So once someone has passed this test, then they can graduate from their program, but it doesn't end there. When you're a practicing teacher, there are professional standards as well. So whether you're like a beginning teacher, you've maybe taught for 5 or 10 years, or you're really an expert, you've taught for 20, 30 years, or you might be a principal or a leader in your school, like a department head. There are different standards at the different levels, but all of the standards have numeracy and literacy in them. So within the classroom, in your teaching, which matches with the curriculum, but then the outside of the classroom stuff too, like analyzing data from students or large scale tests, budgeting, planning field trips, all of those things are expected from practicing teachers. So as we mentioned, and we've given you a few examples, you can incorporate numeracy across the curriculum in all the subject areas. There are lots of ways, even in subjects that people might think, oh, there's not much numeracy in that, like English or languages. Sometimes people think, oh, I don't see any connections there, but there certainly are. And so we'll be back again next year doing a much more in-depth program. This is just a brief introduction today. So if you're interested in, getting some teaching examples and how you would incorporate numeracy in your teaching, do make sure to come back next year and work with Hazel and I, as well as Gil and Helen, and we'll help you to develop your skill set for incorporating numeracy across the curriculum. So we will wrap up there. Again, thank you for coming. We're just amazed at how many of you are here. What a great turnout. And we're always happy to answer your questions. If you want to email us, again, there's my email and Hazel. So again, just first name dot last name at monash.edu.
Yeah.
Okay, thank you very much for your presentation, Dr. Hazel and Dr. Jennifer. I think our teacher is very interesting with your materials. So there are many questions here, as you can see in our chat room.
Sure. It's nice to see, everybody chatting, because it's very lively, and it shows that you are all very interested and you're following what you're saying. And it's okay to have questions. I think that is one thing to note, that, don't, I think sometimes, when we are teaching, right, we expect the answer like so quickly, and our students also expect us to answer their questions immediately. But actually, it's better to let your students to think about it. Maybe you can think about it, brew it. Maybe after the next day, when you come up with the answer, it's like, you feel more empowered. So we'll try to answer all, as much as possible, but there might be some questions that, that you can still keep thinking about.
Because our time is limited, maybe you can answer this question first, from Hidayati. How to improve the teacher's ability to have more awareness on learning maths outdoor? Can you see the screen?
Yeah, so definitely lots of different ways to think about doing math outdoors. But a lot of it comes down to, having the exposure to different ideas and sharing resources. So, if you've done something that's worked really well outside, sharing that with your colleagues. If, there are teacher conferences you can present at to share those ideas, because we do know from the research, from lots of different countries, that when kids can move around when they're doing math, that they actually learn it better, right? And it sticks better in their mind and their understanding, compared to, just sitting and doing everything in books and written. So, lots of things you can do, even just like if in your playground on your school or, out in the yard, right? Having, like a hundreds chart that you make, just kind of paint on, on the tarmac, or, a long tape measure that kids can walk along and treat it like a number line that you can walk forward and walk back if you're adding and subtracting or multiplying, right? Say 3 times 2. Well, that means you're taking 3 steps that are 2 in length, whatever your unit is, right? And that they're physically doing that really does stick better in their mind, and understanding what does it mean, to skip count, to multiply, and so on.
Yeah, and I think, in terms of outdoors, right? I can think of scouts. In Indonesia, you have a lot of scouting activities, right? And in fact, Gillian and I have been working with some of the Indonesian teachers on higher order thinking skills. And I can see one of our Indonesian teacher, Didi, who is there on the screen with the raised hand. So Didi, do you want to share a little bit about what you have done in terms of outdoor mathematics? Anything with the scouts and, maybe not mathematics, but maybe numeracy? Hello? Oops, I'm not sure whether he's able to hear that or able to unmute.
Host, can you?
But it's okay. So, because I can see that some people have raised hand also, so that's quite interesting. So so I think one thing you can think about in terms of outdoors, right, is to look at what existing outdoor activities you already have. So just now I mentioned about like scouts, right? So there's a lot of scouts teachers who are actually doing very good work. So so if you yourself, maybe you did not have the confidence, or the teachers may not have the ideas, you can talk to a scouts leader or the teacher, and then maybe you can work together with other teachers who are more sort of familiar with the outdoors.
Yeah, and especially like lots of things that you would do as a scout, right? You do a lot of map reading, orienteering, if you're building like for a campground or that kind of thing, right? All of those things involve numeracy.
Yeah.
Yeah.
Yeah. So I think it's already 11 o'clock now. Are you okay if there is one question?
Oh, okay,
Sure, we can answer one more. That's fine.
One question more. Okay. Yeah. The students who have weaknesses in mathematics automatically have low numeracy skill. This is from Ihsan, SD Islam, the Green Camp, Tanjung Pinang.
Yeah, so I mean, I think it really comes down to how are you defining what weakness in math is, and what does it mean to be good at math, right? So if you're thinking of good at math as like being really fast to answer and, being able to do a lot of questions from a textbook or a worksheet, or do really well on a standardized test or a timed test, if that's the way, you're conceptualizing that, that's very, very different from what, is needed in a numeracy situation, right? A lot of what happens in mathematics classrooms is not what happens when we do real world math or when we do numeracy, right? When is anything ever a timed test in real life, right? It's very rare that would happen, right? If you figure out in half an hour and 5 minutes or 10 minutes how much stuff you need to buy to make the birthday cake, it doesn't matter because it's not a race, right? And the kind of thinking that's involved is quite different, if math is being conceived of in that kind of narrow way that's very rote and memorization and, focus on speed, that's very, very different. As well as the fact, kind of like the example I mentioned with like the people in our class that were art teachers or drama teachers or whatever, right? Sometimes people shut down in math class because they've already said, I'm not a math person. I'm not good at this. This isn't my thing, right? But when you put them in a context where they're like, yeah, I'm a good dancer, I'm a good musician, I'm very comfortable understanding fractions as, music notes, then they're very confident and very competent. Like I actually, when I was teaching in Ottawa, I was teaching pre-service teachers there. And I had one student who, again, was a musician, quite strong musician. And she said, like, when I'm dividing fractions, I never use an algorithm. I never use a formula. I think about it as notes. And I think, okay, if there was a quarter note, how many 30-second notes would fit into or be played at the same time as that one quarter note? And that's how she did division of fractions or multiplication of A. And I think that's a really nice example to show that, people are very, very capable of doing math lots of ways. We have to make sure what they know lots of ways.
Yeah. So totally agree.
Okay, I think, that's the end of the session because due to the time allocation, we are sorry that we cannot accommodate all the questions. On behalf of Directorate Teacher for Basic Education, Ministry of Education, Culture, Research and Technology, we would like to thank to our speaker, Dr. Jennifer and Dr. Hazelton for the presentation. It's very fruitful for our numerasi teaching learning practitioners. I hope we can continue our collaboration next time. And we can meet you again in another series of like this webinar or Zoom sessions. So see you on another occasion. Thank you very much, Dr. Hajar and Dr. Jennifer Tang.
Thank
You're
you.
very welcome. And thank you. And thanks everyone for coming and for the nice comments.